The Solid Combustion Experiment Module, called SCEM, allows us to study how various materials burn in a microgravity environment. On May 21, 2020, the SCEM was loaded onto the H2 transfer vehicle Konutori 9 and transported to the International Space Station. Astronaut Soichi Noguchi installed SCEM in the Kibo Japanese experiment module. With the SCEM, we are able not only to burn a sample material in space, but to use multiple cameras to observe how the flame spreads. Footage from these experiments will give us important data, such as the shape of the flame, how fast the fire spreads to consume sample materials, and how far heat is conducted ahead of the advancing flame. The SCEM unit is mounted in the multi-purpose small payload rack, known as the MSPR, which is part of the Kibo experimental module. The larger space, which we call work volume, houses a combustion chamber for experiments, a camera system, a ventilation unit, and a power and communications control unit. In the small experiment area underneath, there is a gas canister filled with a mixture of oxygen and nitrogen, which is essential for combustion experiments. There are two types of experiment inserts. The first holds electrical wire samples. The second holds flat samples. Experiment Insert 1 has two types of ignition. One induces a strong electrical current in the wire core, achieving self-ignition. The other ignites the sample using an external heat source. This insert allows us to burn an electrical wire that feeds continuously from one reel to another. The unit can accommodate electrical wire samples that are 1.1 millimeters in diameter or even smaller, and up to 81 meters long. An experiment with an electrical wire cannot be recorded properly if the flame moves along the wire at a different speed than the wire is moving from one reel to the other. In order to keep the fire at the center of the module, the speed of the flame is measured with a visibility camera, and the speed of the wire feed is adjusted accordingly. Experiment Insert 2 is used for flat samples. Samples are stored in a special cartridge and can be loaded remotely without the help of the crew. When an experiment is finished, the sample is automatically placed in a retrieval cartridge. In this experiment insert, we can use flat samples up to 140 millimeters long, 50 millimeters wide, and 4 millimeters thick. What about the environmental conditions inside the SCEM? The oxygen concentration inside the combustion unit can be set to any desired level using nitrogen supplied from Kibo and mixed gas containing 45% oxygen and 55% nitrogen from the gas canister installed in the MSPR. Atmospheric pressure can be set to a maximum of 2 atmospheres. The combustion chamber has a flow straightening function. Igniting the top of the sample allows data to be obtained under concurrent flow conditions, while igniting the bottom creates countercurrent flow conditions. The built-in fan allows the flow rate to be set anywhere from 0 to 25 centimeters per second. The combustion chamber has an air filter that allows the removal of carbon dioxide, water, and soot generated by combustion. The SCEM has 5 cameras that record combustion phenomenon. 3 are visibility cameras, 1 a high-speed camera, and 1 infrared. Each can be individually controlled. Recorded images and videos can be downlinked to the Tsukuba Space Center via remote control from the ground. Visibility Camera 1 is positioned diagonally above the combustion chamber. Visibility Camera 2 is at the top of the unit. To capture the sample directly from above and to accurately observe the speed of the spreading flame. Visibility Camera 3 is positioned on the side. To capture the sample directly from that angle and to observe the shape and appearance of the flame. The high-speed camera is positioned diagonally above the combustion chamber. The maximum frame rate is 55,000 FPS with a resolution of up to 3840 by 16. The infrared camera is right next to Visibility Camera 2. It captures the fire from directly above and records the temperature of the spreading flame. The infrared camera can measure temperature from 20 to 500 degrees Celsius. It provides still image files at a rate of 30 FPS, converted from raw data files to JPEG. The SCEM also has instruments such as highly precise oxygen sensors and sensors that measure CO2, flow rate, and temperature. Oxygen sensors are installed in 2 locations with a measurable range between 0 and 45%. There is 1 CO2 sensor with a measurable range of 0 to 3%. This is the flow rate sensor. Its measurable range is 0 to 5,000 centimeters per second. There are 3 temperature sensors with a range of 0 to 100 degrees Celsius. Given the importance of space fire safety research, NASA is also conducting solid combustion experiments on the ISS. Compared with NASA's experimental equipment, the SCEM has the following features. First, the automated sample exchange mechanism allows combustion experiments to be performed efficiently and repeatedly, while reducing crew operation time. Second, combustion experiments can be performed under conditions of low pressure and high oxygen concentration. In future manned space expeditions to the Moon and Mars, spacecraft may have low pressure and high oxygen concentration, a different environment from today's space missions. So it's important to study material flammability in such conditions. In addition, only the SCEM allows studies such as wire sample overcurrent ignition experiments. The first project to use the SCEM is FLARE, the Flammability Limits at Reduced Gravity Experiment, which was adopted as a priority research category for Kibo in 2012. With the FLARE project, we will study the flammability limits of individual materials under arbitrary flow rate conditions by running multiple tests with different oxygen concentrations. This research is crucial preparation for human space exploration in the near future. Japan is contributing to our safety and security in space by taking the lead on developing and establishing international evaluation standards. This was an introduction to the Solid Combustion Experiment Module, known as SCEM. How did you like it? Today, the SCEM is being used to conduct combustion experiments in microgravity. In the future, we are considering adding a gravity generator so that we can create conditions of 1/6 or 1/3 gravity and better simulate the conditions on the Moon or Mars.